class will work, yeah? In general, guys, you don't need permission to go get more food. Just walk out, get more food, come back in. If you want to use a loo, let me know. I don't think the bathrooms downstairs are open. I'll open with the teacher restroom, all right? Ooh, we have like sofas. Yeah, it's like warm seats. Okay. These practices that we're doing are by people who actually contribute to the actual release exams, right? So if you look at question number 1, it says f equals x squared plus bx when x is less or equal to 5. It says 5 sine pi over 2x when x is greater than 5. So what's the concept of continuity again? Limit equals value is the limit, basically the left guy and the right guy, top guy and the bottom guy. Okay, so you can plug in 5. 5 squared is plus 5x. And then, sorry? Oh, yeah, 5b. And then the bottom guy is 5 sine 5 pi over 2, correct? This is fair game on the AP exam, where they ask a multiple of pi or pi over 2 that's not conventional, but we can work it out. Is this 1, pi over 2, 3, 5, which is basically 1. And we can solve that, yeah? We're just setting up to say, okay, I got the hang of this. Okay, copy down number 2, just the function. We'll talk about the strategy. Look carefully. It says relative min, or relative max. But what might I do first step? Read the question.
Rewrite.
Thank you. So, Mazu, it occurred to her naturally. It's tempting to leave it alone and take the derivative. The first step should be negative x cubed plus 3x squared. Correct? So, as a strategy, if you're writing with good notes on highlighter, highlight, rewrite. Okay, that's the strategy we're using for that question. This is fairly straightforward. Let's just discuss the concept. What's the concept of horizontal tangent again? I'll help you. We said the top equal to 0. We have horizontal tangent. So you have dy over dx equal to 0. So we said the top equal to 0. Okay? That's the important idea. Again, you can highlight that guy. Oh. Write down that function. It looks weird, but actually it's an easy problem. So number 5 says limit x approaching infinity 10 to the power of 8 x5 plus 10 to the power of 6 x4 plus 10 to the power of 4 x squared. So these are all AB, BC overlap problems. Now I'm calculating the infinite limit. So think back, we should only consider the leading term. Is the leading term only that guy? And therefore, careful. So what's your final answer? 0. Leading term on the bottom is higher, so just 0. You don't need to actually do any work. So don't take derivatives or anything like that. Copy that down. Again, so in the recent past, we've discussed weird-looking limit problems with integrals in them. So again, an ABC overlap problem. How do we always do limit questions? So you plug it in, will you get 1 to 1? So it is 0 and then 0, 0. So we are, now I'm going to apply L'Hopital's rule. So what concept will kick in on the top? FTC2. So it looks weird, but that's fine. So plug in. So you get cos 1 plus x over 1 plus x times 1, the derivative, slow and steady, over 1, correct? Don't forget the word limit, and then the answer shows up. We plug in x to be 0, the denominator collapses. This is 1, correct? And then final answer? Sorry? Cos 1. Again, it looks weird, but that's okay. The answer is cos 1. Yeah, that is easy. Oh, this is a unit analysis problem. This kind of question appears on the AP exam. It says T is measured in hours. So in your notebook, just say T hours. There's no math required, but they want you to understand units. So T is measured in hours. F dash of T is measured in knots. You may say, huh? But read on. 1 knot is 1 nautical mile per hour. So it's basically miles per hour. And they say, then 0 to 2, F dash of T is, so again, 0 to 2, F dash of T. Oh, and then F dash will be, integral of F dash will just become, this is F net change, F of 2 minus F of 0. Yes? Now I'm showing you units. So you may say, but I wish I had the unit for F. Am I making sense? I don't know the units of F, but I can deal with the units here. Isn't F dash miles per hour? So make a note, please. That's miles per hour. I'm showing you unit analysis in case it's not apparent. And then dt is hours. So final answer is in miles. So observe, the integral just means sum of. But again, I did units here, units there, cancel, it was in miles. So have a look. So nautical miles. That's the answer. Oh, this is a good question. Sketch the figure? Yes, go on.
How come it's not just knots?
No, but a knot is miles per hour. They gave you.
So are your books options?
Sorry?
The answers have both. So
Yeah, but we're choosing miles. Have a look.
Why is it?
No, but knots is not true. Again,
Oh, okay.
again, it's okay. Okay, sketch that question quickly. We've discussed this in the last couple of days. Again, it's an ABBC overlap problem. Sketch that figure, label ABCD quickly. Label, the y-axis is velocity, keep that in mind. And the question says, at which points is the speed the greatest? So let's go with the formula again. What's the definition of speed again? Absolute value of velocity. So in other words, we need to consider positive and negative values. But now it's a gimme problem. So in which point is the absolute value of velocity the biggest? And the answer should be D. Okay, that's a large negative number. When you take absolute value, it turns positive. So the answer is D. In your notebook, just say speed is greatest. The answer is D. Everybody okay there? This is a gimme series problem. This is a copy down that question. This is a conversation I was having with Miss Dong and Mr. Park in class. That's an ABBC overlap question. Rubles, can you put that black chair, fold that black chair, put it there, and then use the rolling chair? You'll be far more comfortable. Just put it against any desk. Yeah, right there. See, we're far more comfortable. Mm-hmm. Okay, guys. So make a note, please. Make a note. So these are your notes. So highlighted or whatever, use a different color. I want to discuss an important idea. which is this. In general, if I say we have a relative max or relative min or relative max, and likewise inflection point. This should be true. So f dash switches signs. And this should be true. F double dash switches signs. That's the definition. So there's nothing to argue. But on the other hand, the question says at x equals a, we have a relative min or max. I'm going to write something on the board, look at the board and say, oh yeah, that's true. If it's a relative min or max at a, and it's a polynomial, especially for polynomial functions, or a trig function. You guys know how trig function works. Can you see then f double dash must have a horizontal tangent? Sorry, f dash of a should be 0. So these are two different ideas. If I just say in general, I have a relative min or max, f dash which is signs. But I say at a, and then likewise, if you have an inflection point, f double dash of a should be equal to 0. So those are two very different ideas. Do not mix them up. But don't say, Ramabri, you said f double dash I can set it equal to 0, and we should be, no, because I gave you. So have a look here. It says at x equals -1, we have a point of inflection. So should f double dash then be equal to 0? So I can find f double dash. Let's do this very quickly. So f dash will be 4x. We're taking derivative. That's over k. Minus k over x squared, right? It's 1 over x squared. Now, how do I take double derivative? Should I write that on top? Please understand that's x -2. So f dash will be 4x will become 4. And then it'll become positive 2, k, and then x to the power of -3. Rewriting it 4 plus 2k over x cubed, right? And I know at -1 I have a point of inflection. So I can do f double dash of -1, which is 4 minus 2k. I can set equal to 0, k equals 2. So I don't have to do sign switches. No. It's a regular function. I just wanted to emphasize that idea. Okay, this is a simple problem. Oh, for 16. Now all of you are aware of it. We're not going to do the problem. This is only a BC problem, Ms. Robles. Just make a note to yourselves in the last step. So draw a skull, as in we're taking notes. In the last step, condense carefully. So if you made a sign mistake, it's going to show up later. So condense carefully. So observe. The answer is C, D, or E. Can you see, depending on which one is negative, this guy's positive goes on top. This guy's negative goes on the bottom. Over here, both are positive, so we condense product. So make a note about using log rules. Let's just write the formula for review purposes. Just make a note x of t, y of t. This is a BC only problem. Mini challenge, write down the second derivative formula for a parametric function. I kind of emphasize, come prepared by studying the Bible, otherwise you use the leading points of the table. So don't forget that dy over dx will be y dash. Okay, who remembers the second derivative formula?
Y
D?
Y over dash.
Yeah, you mean dy dash over dt.
Yeah.
Over dt, all over
DX.
dx over dt. And make a note, y dash is this guy, the first derivative. So sometimes you may have to use quotient rule, sometimes you're good to go. Okay, that's straightforward. 19, just write, copy the question, we'll only set up the problem. Ms. Robles, this is an ABBC overlap problem. Oh, nice problem. Actually, we're going to lower sum. Ooh, weird problem. By the way, what is usually given in a Riemann sum problem? A table. So first step, make a table, right? We won't make the entire table, we make the first couple of values. So this is x, this is y. It says how many rectangles? If you're going from 0 to 6, and there are 3 rectangles, what should the width of each rectangle be? 2. So this is 0, 2, 4, 6. Let's plug in 0, you get 2. 2 squared, 4 plus 2. 4 minus 4, 0. This is 2 also. 4 squared, 16 plus 2, 18 minus 8 is 10. And then 6 squared, 36 plus 2, 38 minus 12 is 4. 26. Here's another reason this is weird. Read the question. Do they tell you which Riemann sum? So, guys, it just says which is the lower one. I'm going to say something profound, think about it and say, oh yeah, that's true. Aren't they only ones that underestimate or overestimate dramatically either a left Riemann sum or a right Riemann sum? So this is a trick question, make a note. The specific Riemann sum was not provided. Not given. So the way to approach the problem was calculate the left Riemann sum and right Riemann sum. And then choose the smaller of them. It says the lower sum. Smaller. We've never discussed a problem like that. They wanted you to do a left Riemann sum and a right Riemann sum and figure out which is the smaller guy. Because I don't know if it's increasing, decreasing. I can't make a sketch. Look at me, please. Do you understand that if I had a sketch, I could figure it out? So, for example, 0 to 6, is that increasing or decreasing? X squared, is that a parabola going upwards or downwards? Upwards. So, you can figure it out. Okay. Alright, it requires more work than I'm interested in. So, this will be a left Riemann, sorry. That will be a left Riemann sum. Probably I need a right Riemann sum. So, you can have an underestimate. You see the figure? But I'm just showing you, it could be done, but it requires more work. Oh, here's your first exposure to a multiple choice question requiring something called a slope field. Let me dim the lights. Okay. I think there's another document also, because I'm going to give you to practice on slope fields. Duplicate. I was working on a document this morning. I hope it came up here. Ms. Robles, please pay attention. This is an ABC overlap problem. 645 again. So I'm going to show you what is a slope field problem. There you go. So have a look. I'll give you 30 seconds. We'll copy that slope field, please. I'm kidding. Oh my God, you guys are adorable. Really? You want to copy that? That is so adorable. Okay, anyway. I want you to copy the choices, please. Copy the choices. I'll show you how to work the problem. Okay, the A, B, C, D, E. Again, copy the choices. I'll show you the strategy to figure out so if you were present on Friday, we discussed an idea called slope fields. So I'm going to show you how to work the choices. So it says dy over dx equals 1 plus x. B says dy over dx equals x squared. C, dy over dx equals x plus y. D is dy over dx equals x over y. So I'm showing you, now put your pencils down please, so I can show you, you can direct your attention to the board. Again, magnify this a little bit. Okay. So the first basic strategy is this. I'm going to work choice A out. So the way it works, Ms. Robles, is this. Everybody, pay attention. If I plug in certain values, that'll give me the slope. I can see whether it's positive or negative. Is that clear? But here's a clever strategy. If x is -1, so in your notes, write this down, please. Figure out, again, determine very, very quickly where f dash equals 0. So you can eliminate choices. So look at my strategy, please. If x is -1, will the slope be 0 everywhere? So I need a flat line. So again, make a note, we're working on A. So if you have some room next to A, add x equals -1. Y dash should be 0. In other words, I'm looking for a flat line. So let's have a look. Add x equals -1. Do I have flat lines? No. So A is out. That's out. Okay, I'm showing you how to work the choices. Next, let's discuss B. When x is 0, will the slopes be 0? What does it mean when x is 0? You should be on the y. Okay, x is 0 on the x-axis or y-axis? Y-axis, make a note. So I'm showing you the fastest way to work the problem. So on the y-axis, all the slopes should be 0. In other words, I'm looking for a flat line. Is that true? No, that's out. Okay, now observe this guy. Observe this guy. I'm basically setting it equal to 0. Does that not mean, I'm blowing your minds, y should be exactly negative of x value? For those of you not aware, write some notes. If y equals x, isn't that the 45-degree line over there? So the slope should be 0, if y equals x. If y equals negative x, that's the negative 45-degree line, like that. There the slope should be 0. Is that true for this graph? Oh, that's actually true. Have a look on this diagonal. So y equals negative x. So this is a possibility. This is a possibility. Now I'm just going to, oh, by the way, this is the answer. This is the answer. Okay, but I'm just showing you another thing. Let's have a look at this guy. Let's have a look at this guy. As before, when x is 0, is the slope 0? And x is 0 on the y-axis, and that's not true. The other strategy I want to show you is this. Assume for a second there were two choices like this. So there was another one like this. Say, I want to make x plus y equal to 0. I don't know. Okay, but I'm showing you a second strategy. So write down strategy. Is this, take test values. Use test value. Oh, by the way, there are notes on this on the Bible. Only we haven't covered it. So make a note. Use test values in each quadrant. In each quadrant. To eliminate choices. Let me show you the strategy. Put your pencils down. So I'm going to eliminate this using this strategy. This says, look at me please. This says in the second quadrant. In the second quadrant. Oh, in the first quadrant, will x and y both be positive? So should I expect all the slopes to be positive? That's true. Okay. Let's choose the second quadrant. In the second quadrant, is x going to be negative? But y going to be positive? So the ratio will always be negative. Ooh, but I have positive slopes here. That's out. So I'm showing you the strategy of how to eliminate by using test values in every quadrant. Now that you understand how to do this, let's work on this problem. There you go. So it says shown above is a slope field with differential equation. Can you please copy that down? Copy the choices down. And we'll apply a strategy based on that. So I will use two strategies based on when the slope is 0 or test values. I'll eliminate choices. So I want you to be alive and engaged. Don't just passively nod. So according to A, the slope will be 0 when x equals 1. So again, y dash is 0 when x equals 1. Let's see if that's true. Let's go to x equals 1. At x equals 1, is the slope flat? No, so that's out. Let's look at choice B. Choice B says dy, I love myself. X minus y. Therefore, the slope will be 0 when x equals y or y equals x. Is that the 45-degree line? Let's go to the 45-degree line. No, not even true. Again, only there should we have flat tangents. So that's out. Okay, let's do C. dy over dx equals negative x over y. The slope will be 0 when x is 0. You must be on the y-axis. Let's have a look at y-axis. We have flat slopes. No. It's going like that. So they're almost vertical slopes. So that's out too. Let's have a look at D. That's weird. Y squared is negative 1. Can y squared ever be negative 1? So in other words, they are saying the slopes are never flat. And let's see if the slopes are getting flat anywhere. Actually, the slopes are getting flat here somewhere, right? here, somewhere there. You see that? All right. So D is out. It's E. The answer is E. But I'm going to show you a couple of ways to do this. Oh, by the way, the slope is 0 when Y is 1. Let's have a look. Oh, we actually just discussed it. Remember? Here, somewhere here, the slopes are getting flat, like that. Here. So it's getting steep. This is fairly steep and getting flat and flat. Somewhere there is going to get flat. But let me show you the test value strategy. Let me show you the test value strategy. Let's have a look at that guy. In the first quadrant, our x value is all positive. What's 1 minus a positive number going to be? A negative number once you cross 1. So this says to the right of 1, you're always going to be negative. This is, but here they're positive. Can you see that? So that's out. To the right of 1, my slopes are always negative. But that is false. We have positive slopes. So you choose the test value strategy along with the slope 0 strategy. Is that clear? Okay, this is a BC problem. Take that problem down. As a general tip, focus on the nth term. And the nth term tells you it's see, she quickly recognizes geoseries. So it's 2 to the power n minus 1, x over n minus 1. Summation goes from 0 to infinity. What's the first term, obviously? One. What's the common ratio, obviously? Sorry? 2x, correct? You take the common ratio. It says interval of convergence. So is that just 2x less than 1 using a geoseries? Is that clear? So the answer is negative 1/2. Okay. So the strategy of this is look for the nth term and geoseries. That's the first question you should ask yourself. Is that a geoseries? You're wasting time if you're doing a ratio test. Okay, this is a straightforward problem. Oh, this is a lovely problem. Relax, rulers. It's a BC problem. Just copy down that expression. This is a difficult BC problem. It says a to b, e to the power of 2x plus 2, e to the power of x plus 2 dx. It says if this is the length of the curve, which of these could f of x be? So you have two strategies. One strategy is work the choices. Okay, but I'm letting you know the actual choice was D. By the time you work the choices, it's tedious. Can we work backwards? What's the length of the arc formula? Square root of 1 plus f dash of x squared dx, correct? I'm showing you a backward strategy. How to be smart about it. So, what should f dash of x squared then be? Use common sense. This is 1 plus f dash of x. So what should f dash of x squared be? e2x plus 2ex plus 1. Do you understand? Working backwards. It should be e2x plus 2ex plus 1. Therefore, what should f dash of x be? Should it be the square root of this guy? Everybody okay there? It should be the square root of this guy. So this will be square root of that guy. That can actually be factored. Do you see the factoring? That is what square? See your advanced algebra skills. It is a square of a number. Very good. It's ex plus 1. Because, don't forget, ex squared is ex plus ex times ex, which is you add powers, e2x. Will the middle term be 2ex? So you have... and then last step, that was f dash of x. What do we need? F of x. So the integral, the choice is e. Yeah, so integral of f dash of x dx will be ex, and what's the integral of x? 1. X plus c. The answer was e. Okay. So we work backwards to figure out how it works. Because it's a constant, silly. When I take derivatives, it's going to vanish. It says could be. Oh, I said e. Ex plus x plus some constant when you integrate. Okay. We won't do it, we'll talk about it. If I want h dash of 3, what should I find first? Of x. Then product rule, you're just using product rule. Is that clear? Oh, this is an ABBC problem. Let's do this in our heads. It says x approaching infinity, f over g should be 0. So I'm helping you. No, don't look at the choice. I'm showing you. Do some thinking first, then the answer. If that should be 0, the top guy should rise faster or slower? Slow. Is that easier? So do the thinking. Otherwise, you're doing this. So top guy should rise slower. So the answer should be C. So strategy is think first, then look at the choices. Oh, this was there on your FRQ, one of the FRQ take-home tests. There's only a BC problem is on this. So it says 1 to 4, t minus 2 over t plus 1, t minus 4. Okay, we haven't discussed this kind of problem. Here's the problem with this question. Do you observe that 4 is actually a vertical asymptote? You observe that. They want you to observe that. So in other words, I'm basically taking, because when you plug in 4, you actually get infinity. So we're basically taking the limit. You can't be 4. You can't be 4. It's basically like you're approaching 4. So the correct answer was scroll down. So that you're taking limit b approaching 4 minus. Is that clear? What's the difference between these two guys? Oh, this is 1 to b. That's it. No, actually this guy. So 1 to 4. So make a note. The correct answer was limit b approaching 4 minus 1 to b. T minus 2 over t plus 1. T minus 4. So in your notes, write down t equal to 4 is the vertical asymptote. So this is really, you're approaching 4, but you can't be 4. See, you're 4 minus. While I'm here, take some really good notes down, please. It's going to appear in one of your take-home multiple choice tests. Now, guys, the bad news is this. When we come back from break, the multiple choice tests you're taking are actual AP tests from the year 1997 onwards. So it's getting really close to being recent. All right? So here's a power tip. If you have integral, I'm just making this up. Say 2x plus 1 over, say, x squared minus 1 dx. And I go from, say, negative 2 to 0. Which method should I use? Louder? Long division. Partial fractions. Silly girl, the higher power is in the bottom. Okay. Now, here's a problem. We've never actually thought about this, but I'm letting you know the AB will kind of force you to think about it. One of the choices may be, write down the choices. One of the choices may be divergent. But you may say, Rama, using partial fractions, we've never got an answer to be does not exist. Because you want to check for the vertical asymptote. What are the vertical asymptotes here? 1 and negative 1. So are you not actually crossing the vertical asymptote? Make a note. The vertical asymptote is x equals plus or minus 1. So if you're crossing the vertical asymptote, the answer does not exist. Don't take my word for it. This is what is going on. So I'm just going to make a rough sketch. X-intercept, negative 1/2. Y-intercept, negative 1. Vertical asymptote, plus or minus 1. Okay, I got it. So it's, and then horizontal asymptote, 0 plus 0 minus. So this is how the graph is going. Okay, this is how the graph is going. Sketch the graph, please, so you can illustrate what is really going on with the curve. And the question says, find the area from negative 2 to 0. Do you understand? It's divergent, does not exist. You have an infinite limit, it's going up forever. Again, it's going down forever, it's going up forever. This area does not exist, so the answer is divergent. Now, how might you know that? Again, you're not doing partial fractions. You're checking, do I have a vertical asymptote in that limit? Okay. Make a note that I have a vertical asymptote in that, this thing of negative 2 to 0. So the answer is does not exist. So as a trick, if you see one of the choices to be divergent, check if that's the case. Is that clear? If it is not, proceed with partial fractions. Okay. So make a note, check before partial fractions. We mechanically do partial fractions. I'm asking you to be smart and actually check if that's the case. Oh, okay. I want to discuss this. This is an A-B-B-C overlap problem. Students rollers, you can participate. Oh, yeah. Oh, yeah. Take this problem down, please. Take this problem down. It says average value of cos x in the interval -3 to 5. It's in page 1 of the Bible, in the prerequisite skills. This comes in honors, but not in IM3. But in honors, Ms. Belo does discuss this idea. What's the definition of average value again? 1 over, so what am I writing? 1 over 2 or 1 over 8? Slow down. 5 minus -3. Slow down. Show the word. Integral -3 to 5 cos x dx, yes? So is that 1 over 8? What's the integral of cos x? Just sin x. Lower limit? Upper limit? Let's plug it in. Look down. Brackets, sine of 5 minus sine of -3. Bad news. Look at the choices. None of the choices match. Because you need to know a trig identity. It's there in the Bible, page 1, under negative identities. Write this down, please. You need to know that sine of negative x is negative sine x. Tan of negative x. Sine and tan go together often. Negative tan x. But cos of negative x is positive cos x. For the kid with the advanced skills, sine and tan are odd functions. That's why. Cosine is an even function. So stand at the board and memorize it. Again, it's page 1 of the Bible. So now look down, please. Look down. So sine of -5 is negative sine 5. 2 negatives make a? So final answer. Sorry? It was sine of -3 then. So it will become sine of positive sine 3, right? So positive sine 3 and positive sine 5. So is that E basically? Now, a similar problem is appearing on the question these guys created. Let's do that one. So they're mimicking that, but this time, oh, it's visually identical then, right? It's cos x, but it's cos x over 2. So integral cos x over 2, integral from -4 to 0. The average value, so what should the outside number be? Careful. Just 4. 0 minus -4. Okay, careful. Cos of x over 2 is sine of x over 2 times 2 over 1. Okay, multiply by the reciprocal. So the outside number really becomes 1/2, slow down. Okay, and then lower limit, -4, upper limit 0. And then becomes sine of 0 minus sine of -4. We just did the rule. And what's sine of -4 going to be? Negative sine 4. So the final answer is sine 4 over 2 then. Oh, sorry, over 2. This is over 2. Sine x over 2. So sine of 2 over 2 then. So the answer is E. Okay. So I wanted to go over that thing. Oh, so the other kids absent, I mean, they have to work these choices. You're learning some brand new formula. So write down the limit definition of a Riemann sum. So limit definition of an integral. Integral a to b f of x dx. Now keep in mind, it's the area under the curve, so it's basically the sum of infinite rectangles. So this is the formula. So write this down and memorize it. Limit n approaching infinity. Summation I goes from 1 to n. F of a plus delta x times I over n times delta x. Relax. And this is an AB problem also, Ms. Robles, so write this down, where delta x is given as b minus a. It's basically the base of the rectangle. Okay, put this in a box, please. Relax, we'll do at least 3 examples so you'll get it, saying, okay, I get it. I'm just plugging it in. So A is the lower limit. That's the width of the interval. Okay. Trying to recall if I'm making a mistake. Is the outside here delta x or delta x over n? I don't know. One of the earlier versions of the Bible. Yeah. Oh, I goes from 1 to infinity. Oh, you did. Oh, okay, I get it. Okay, guys, sorry, it's just delta x here, and it's delta x is b minus a over n. Okay, it's fine, b minus a over n. Change the formula, it does not have a denominator there. Now we're good. Yeah, this one does not have a denominator. So delta x, the width of each rectangle is the difference, b minus a divided by n will give you the width of each rectangle. Okay, we'll do a couple of practice questions based on that formula. Relax, I'll guide you. Yeah. So copy down this question, please. Okay, copy down the expression. Again, this is an AB-BC overlap problem. We'll just work the choices, nothing clever. We'll just work the choices. Oh, sorry. Okay, copy down the question, and then let's see if we can expand the okay. And then copy down some of the choices. Copy down A, B. We can eliminate many of the choices actually. I have the answer already in my head. Just because of clever elimination of choices. According to this, I should have a 1/2 in my answer. Do you see it? I have 1/2 here. So A is out. I should have a 2 somewhere there. 2 is not here. That's out. This says I must have radicals. That does not have a radical. C is out. In my head, it's B. But let me show you why B is the answer. So copy down B, please. Focus on B. So B says 0 to 1, radical x dx. I'm going to apply the formula. So write this down, please. So f of x is radical x. A is 0. B is 1. Alright? I'm just going to plug everything in there in the formula. And the answer will magically show up. So stay with me, please. So it's basically limit n approaching infinity, summation f of A, which is 0, plus delta x, which is b minus a over n rectangles. B is 1, A is 0 over n rectangles. So that is 1 over n. So f of 0 plus, I'm plugging the formula, 1 over n I times delta x, which is 1 over n. Okay. Will this just collapse to limit n approaching infinity, summation f of I over n? 1 over n. I'm not doing anything clever. I'm just plugging into the formula. Okay, 0 plus 1 I over n is his answer. So I'm now going to plug that into the formula, please. So f of x is nothing but radical x, correct? So it's limit, n approaching infinity, summation. So will that become radical of I over n? Again, I just replace every x with I over n times 1 over n, correct? And I goes from 1 to infinity. I'm going to expand that. You'll see, oh, that is the answer. So I takes the value 1 initially. So limit n approaches infinity. Is that 1 over n? I takes the value 2 next. Is that radical 2 over n? Is that the choice they have? See the question. See the question. Okay. So take 30 seconds and observe how I plug into the formula. Take 30 seconds. So you need to memorize that formula. When you plug it in, the Riemann sum will appear. Okay. Take about 30 seconds. Again, the formula says f of that over n. F of x is radical x. So I just replace every x with I over n times 1 over n. And got the answer. Relax, we'll do 3 more examples so you get a feel for what's going on. Yes?
What is the time?
No, it's there. Here, 1 over n. It's there. It's there in the front. Okay? It's there in the front. Let's do another problem like this. Here, take that down, please. Again, I'll just show you how to work maybe one of these choices. Okay, just for the sake of it, let's work D and E. So I will work out D, you will work out E. Alright? I'm working out the harder one, you'll work out the easier one. Alright? So write down f of x is radical x. A is 0. B is 50. Therefore, delta x is 50 minus 0 over n, which is 50 over n. Is that clear? Next, I write the formula. So that integral is basically limit n approaching infinity, summation I goes from 1 to infinity, or 1 to n, it doesn't matter. Here they're stopping at n. Okay. F of a plus delta x I times delta x. That's the formula. That's the formula. Memorize it. Yes. Oh, A is the lower limit, so legal. B is the upper limit. Yeah, I'm just looking at the limits. Okay. Now I'm getting ready to plug it in. Limit n approaching infinity. Summation I goes from 1 to infinity. F of A is a 0. Delta x is as 50 over n. I times 50 over n. Okay, last step. Wherever I see an x, should I replace that with 50i over n? That's all I'm going to do. So, limit n approaches infinity, summation I goes from 1 to infinity, radical of 50i over n times 50 over n. I'm not doing anything clever. You don't need to look at the board. I'm just plugging it in. Okay. I'm going to expand the summation because you can see they've expanded, right? So I'm going to expand the summation. So limit n approaches infinity. Big brackets. Well, the first guy just be 50 over n. Radical. The second guy will be 50 times 2 over n. Or 100 over n. The third guy will be 150, 50 times 3 over n. So, times 50 over n, correct? Is that the original problem? No. You guys try D by yourselves. I strongly believe D is the answer. So check if D is the answer. Okay? Look down. For practice. I strongly believe that D is the answer. If D is not the answer, then B is the answer. Check if that's the expression you need to evaluate. Yes? Limit n approaches infinity. Oh, summation f of I over n times 1 over n. Is that clear? This is evaluated. Limit n approaches infinity. Summation f of I over n. Yeah? Times 1 over n. So I'm going to expand it. Oh, and then they have a 1 over 50 outside, right? Limit n approaches infinity. Summation, we remove the summation. 1 over n times 1 over n. Correct? Plus radical 2 over n times 1 over n. I got the hang of this. If you compare, are they basically choosing n to be 50? If you compare, are they choosing n to be 50? So it's radical 1 over 50 times 1 over 50. Radical 2 over 50 times 1 over 50. But do they have an extra? Do we have an extra 1 over 50? So make a note to yourself, by comparing we found out n to be 50. Do you observe there's an extra 1 over 50 for them? So the answer, if I remove this, will the answer be B then? Have a look. Because B does not have that radical 50 on the side. Okay. So if they choose n to be 50, that's 1 over 50 radical. Radical 2 over 50, 1 over 50. Okay, let's do another problem. The answer is B. Huh? Because here we have an extra 1 over 50. Like, why is there this already? If you look, this already matches what they have. Have a look. I'm going to hide that. This guy actually matches with that. What is that extra 1 over 50 doing? So if I remove this, which is that, then the answer will match up. Yes? No. I'm saying there in D we have a 1 over 50. Can you see? We don't have a 1 over 50. We just have that. No, watch. I'm going to plug in n to be 50. So I will get limit n approach, I will get radical 1 over 50, 1 over 50. Yes? Plus radical 2 over 50 times 1 over 50. Yes? Will this guy match with that? But we have another 1 over 50 in my question. What's going to happen with that guy? That choice is this guy. An extra 1 over 50. We could pull out a 1 over 50, but then I have another 1 over 50. But if I would vanish that, I'll get that choice. And then it'll match up. Okay. We'll do a last question where we're forced to work out the choices. Or maybe one of them will work out faster. Okay, so let's go back to this one. Okay, let's do this one, please. I'm going to just show you how to work out choice A. So I just want you to write the expression, and I'll pick it up 2 steps later. So it says integral 1 to 2, 1 over x dx. So we can be faster. A is, B is, therefore delta x is that 1 over n? B minus A over n. Is that clear? And the expression is limit n approaches infinity, summation I goes from 1 to infinity, f of A, which is plus delta x, which is times I, times delta x, which is 1 over n. Rewriting is your friend. Limit n approaches infinity, I goes from 1 to infinity, is that f of 1 plus I over n times 1 over n. Okay, we're wrapping it up. N approaches infinity, summation. I goes from 1 to infinity. I'm going to replace every x. With 1 plus I over n. So it becomes 1 over 1 plus I over n times 1 over n. I'm going to replace every x. So it's 1 over that crazy guy. Alright? Asum?
The second line, the limit n approaches infinity, what's like, oh, okay.
I wrote a parenthesis by mistake when I took the parentheses in F. Weird. Okay, now I'm going to just plug in I being 1, 2, 3, 4, and I'll expand it. Is that basically 1 plus 1 over n times 1 over n plus 1 over 1 plus 2 over n times 1 over n? Is that the expression they have? Oh, times 1 over. Is that the expression they have? They have the 1 over n outside. Okay, at this stage, I'll give you 30 seconds. Look at the 3 examples, say, man, I got the hang of this. I'm just plugging into a formula, see which one matches, and good to go. Okay. There's usually one question on the limit definition of Riemann sum. Alright? Let's accelerate now. This is a game problem. Oh, let's actually do this. Only for the algebra. Okay, it's not a difficult problem. I'm just showing you the algebra. It says let f of t, this is an ABBC overlap. So f of t equals 1 over t. It says for what value of t? I want to see if you are paying attention to the concept. Is f dash of t equal to the average rate of change of f? Is that m sec equals m tan? You should be alive. So they just asking you to do the MVT. So basically m sec should be equal to m tan. And the letters are a comma b. So what am I writing for m sec? Look down. F of b minus all over should be equal to f dash of t. Okay. F of b is, f of a is all over should be f dash. Hint, f of x is 1 over t. Therefore f dash will be negative 1 over t squared. Yes? Okay, I'm going to do algebra on the left side. Should I take LCMs? What is your common denominator? BA or AB? Top left minus all over b minus a equals negative 1 over t squared. How do we divide fractions? Okay, look down. So that becomes a minus b over ab times 1 over b minus a equals negative 1 over t squared. Who can tell me how to simplify that? I'll give you a hint. Anyone? Yes.
Rewrite a minus b as negative.
Thank you, very smart. She says rewrite a minus b as negative of b minus a. So it really becomes negative 1 equals negative 1 over t squared. So here's the expression. Negative 1 over ab equals negative 1 over t squared. For those of you who say, I have no idea what I'm doing, I'm solving for t. Should I take reciprocals of both sides? Oh, can I cancel the negative sign? Therefore, t squared equals ab and t equals radical ab. So I chose this problem so you can get practice with the algebra. Okay, so the answer. The algebra is tedious. But guys, you're guaranteed m sec equals m tan problems that are more involved. You have to work it out tediously. You don't have an option. Oh, just copy it on the function. This is an ABBC overlap problem. We won't do it, we'll talk about it though. So it says f equals 3 plus integral 0 to x cos of t squared. It says what is the smallest positive value of a such that f dash of a equals 0. Don't get alarmed. A is like nothing but x. Okay. So what would f dash of x just become? Thank you. Are we using FTC too? Because we are doing a dash of x. 3 derivative is 0. FTC 2, that's cos of x squared. Equal to 0. Calculator kicks in. So it's a gimme problem. Okay, don't get alarmed when you see A. So draw a Sculpey. So strategy. They say f dash of C. Make a note that's f dash of X. They say f double dash of A. Please write this down. That's just f double dash of X. Don't get alarmed by those letters. Oh, this is a gimme. I don't want to waste time with this. This is also a gimme. This is a gimme. Look at that problem, please. You don't need to write. Put your pencils down. Ms. Robles, relax. It's a BC problem. That is a geo series. So, do we need to find the common ratio? And the common ratio will be sine pi over 6. Now, keep in mind, sine always lies between negative 1 and 1. So, we're good to go. Sine pi over 6 is 1/2. So, you can do it. It's easy. Oh, this is an ABBC overlap problem. You don't need to write anything. Put your pencils down. So, it says, you will see a release question like this. It says, I have three functions, f, g, and h, close to x equals 0. It says, based on the values given, for which function does it appear that the limit as x approaches 0 is 2? So in other words, they just want limit. What's the definition of limit? Not continuity. What's the definition of limit? Left hand should be the right hand. Alright? Oh, by the way, look at me. Should the value be equal to the limit? No. Make a note, please, for limit to exist. So write this down. So for limit x approaches a, f, to exist, it's only that left-hand limit equals right-hand limit. It may not be equal to the value. Okay. Or equal to the value. But the key thing is only the left-hand limit should be equal to right-hand limit. So put your pencils down, we can just scan the table now. So we're looking for 2. We're looking for 2. So what's the left-hand limit, right-hand limit approaching? Is it 2? So we're good. Is it approaching 2? No. Is it approaching 2? Yeah, but this is weird, right? F of 0 is undefined. But as long as you're approaching 2, we're good. Okay, as long as you're approaching 2. Like they have a hole, perhaps? Yeah. Okay, this is easy problem. This is an easy problem. Oh, in general, nobody speaks. Oh no, this is easy. They give you a dash. Oh, 41. We'll do this. So it says in your notebook, just write, Ms. Robles, not for you. Just write down third degree Maclaurin. She's like, yeah, I saw Maclaurin. I'm like, I don't know what's going on. It says third degree Maclaurin series for sine x. So, what is the sine x function for Maclaurin series? X cubed over 3 factorial plus. Are we good? Are we good? Yeah, third degree. Make a note. They say third degrees. Ms. Marzuk will tell you because she has a good memory. You had a question just like this one of the release questions. Let's do this together. You don't need to copy the question. Let's do it. Let's just do it together. It says the base of a solid is the region the